All right, so let's take a look at how would we model many-to-many in a non-relational database such as MongoDB. In this case, we have an association class. Typically in a relational database, the way we would implement this would be that the enrollment table would have two foreign keys, right, that would refer to the student and would refer to the section. Right? And typically the enrollment table might have additional fields that describe that relationship. Maybe it'll say what grade you got, right, when you were enrolled in that particular section, right? That student got this particular grade when they were enrolled in that particular section. But the classical way of implementing it would be a mapping table in between, right? An association table that has foreign keys to the original records, to the other two records, right, and additional fields that describe that. In non-relational databases such as Mongo, we actually have a couple of alternatives. Right? We could certainly implement it the classical way, where there would be a collection that has references to the original to the other two documents. Right? We could certainly do that. Right? For instance, we could have an enrollment collection and a particular enrollment instance. Right, might have a field called section whose value is the ID of some section instance, right? And the same enrollment document would have another field called student that has it as a reference, whose value is the unique identifier of some student document. Make sense? So this is the classical way we would implement it in a relational database, and we could certainly do this in Mongo. But we have other alternatives. We have other alternatives because we can now embed things other than just a primitive data type. We can embed objects. We can embed arrays of objects, arrays of literals, and whatnot. So, for instance, one other way that we could do this is that instead we could have each student having a field in there of sections whose values are all the sections that particular student is enrolled in. Right? I'm enrolled in section 1, so I have the ID of section 1 in here. Right? I have section 2 in here as well. Now this introduces an interesting question. Right? If the student knows what sections they are enrolled in, does it make sense to also have the sections know which students are enrolled in those sections? Okay? Meaning, do we want to be able to navigate in both ways? Now, this over here, the way we would implement it in the legacy way of the classical way, we could certainly navigate both ways, right? Because we only have one enrollment document that points to both of them, so we can go any which direction we want. Okay. Now, but here in this alternative, we have to ask ourselves, wait a minute. So, do we want to navigate both ways? Do we want to navigate one way only? Maybe, does it make sense that a student wants to see the sections that are enrolled in? Yeah, that sounds right, that a student might have that use case, that they want to see all the sections I'm enrolled in. So certainly, from a student's point of view, I like to be able to list all the sections I'm enrolled in. What about the other alternative use case? Would it make sense that having a section, I would like to see all the students that are enrolled in that section? That sounds like also a valid use case, right? But notice that it's not always the case that you want to navigate both ways. Right? It might make sense to navigate one way but not the other. Right? And certainly this would allow you to do that. For instance, you might only implement navigating from a student down to the sections but not provide the other one. Okay? Or you would provide one but not the other. Okay? Now, if you want to provide both of them, where you can navigate from both places, right, so this introduces a little bit of complexity, right, because there's no way for us to enforce referential integrity, meaning that these two arrays at some point could have different information, right? Where I might say here that student 1, these are the sections for student 1. Ideally, that student would be also listed in the other array. It would make no sense that if I go to, from my point of view, I see the sections I'm enrolled in, but if I look at from the sections, I don't see myself in there. It makes no sense, right? right? So if you want to, it would be our responsibility to make sure that these two are consistent, okay? And that's our first challenge of redundancy. We are storing the same information of enrollment in two different places, right? From the student's place, from the student's point of view, I show the sections I'm enrolled in, but then from the section's point of view, I'm also showing the students that are enrolled in the section. You see it's redundant? And redundancy breeds inconsistency, right? Redundancy breeds inconsistency. Meaning I might, by mistake, update this array, and by mistake forget to update the other array, right? And they will not be in sync anymore, right? Now we already visited this. We already visited this issue in JPA, right? And even in JDBC, where authors and faculty and courses that they authored, they needed to point to each other, right? Because you wanted to know that, be able to answer, hey, here's a faculty, what courses did they author? Yes? But if I ask it from the courses side, I would also like to be able to say these are all the authors that have authored me, right? So the same issues arise by using this implementation. So the first one is this, right? This is a classical way of implementing it. You have one mapping table in between that references the students and the sections that they're enrolled in. So it's a many-to-many, right? That's a classical way of implementing it. So for instance, you would have something like this. You might have a student and a section, and you have references to both of them. So the section and the ID of the section, and the student and the ID of the student. So this would be the classical way of implementing it. The problem with this is that, well, the problem. The only thing to note here is that these are not foreign keys. Right, there is no referential integrity validation here. Right? If that ID actually doesn't exist, right, Mongo won't care. Right? As opposed to in a relational database, this would be declared as a foreign key, right, that references a particular table and references a particular field in that table. Yes? So when you set the value of that foreign key, the relational database would validate. So does that field does that value for that foreign key actually exist? If it does, it lets you do the insert. If it doesn't exist, it'll stop you from inserting bogus data. No such validation here. Okay, no such validation. That validation will come later. Right? When we introduce Mongoose and other libraries, those libraries will do the validation for us. Right? We'll do a lot of the things that you lose at the database level in MongoDB, we regain it at the application level using dedicated libraries. Okay? Right. But again, it is not the. We are eliminating some of the responsibilities from the database so that it can focus on other things. So the other alternative is this, right, where you have students. You have students 1, 2, 3, and 4. Now being able to store arrays of sections that they are enrolled in. Okay, so for instance, student 1 is pointing to section 1 here, and section 2 is also enrolled in section 1. Notice that section 3 is enrolled in two sections, section 3 and 4. Okay, and student 4 is not enrolled in any sections. Yes? Right? Now, ideally, the left-hand side, referencing the sections, ideally has the right-hand side pointing to the same folks on the left side, right? That you have in both cases, right? These match, and since there is no validation, right? You could run into the risk that these are not actually synchronized, right? But again, if you're typically you would not you would use this kind of strategy if it would be going from one to the other, but not going both ways. I just wanted to point out the challenges if you would want to try and do that. Okay. So actually, things that were not implementable before, this many-to-many, right? This many-to-many in a relational database, the only way to implement it was to have a mapping table. Here, in a non-relational database, you don't have to. Right? You could literally implement this because now you can have an array of things pointing to a whole bunch of other records. Right? And vice versa. This could have an array of foreign keys pointing to a whole bunch of records. So there's no need to reify, right? Because they actually can have arrays of multiple foreign keys to go out. Now, so that's if it's a plain mapping many to many, okay, where you have just an array of references going both ways. If you have an association where not only do you have references, but you have additional fields, then the foreign keys are not enough, because where are you going to store the other fields? Right? There's no other fields, right? Because these are just arrays of of references, right? You would need to have, you would have to rely on this implementation where you could have not only the pointers, but additional fields that describe the relationship. Right. So here you have here we have a student. And notice that in student we are retrieving a particular student. We're doing an update. Notice what we're doing here. Notice what we're doing here. We have a student. We're retrieving the student. And we're going to update that student. We're going to modify its sections. We are setting the sections to be equal to an array, which is fine, right? We're saying this student is enrolled in that section. Yes? Right? Now, the cooler thing is that now that there is a sections array, right, that is not empty, there's at least one section ID in there, I can now use another operator. I can use push. Push does what you would expect. Right? It takes an already existing array and adds to it. Right, so here I am updating the same student that I just enrolled in one section. I am now pushing another section ID into the same array I just created on the line before. See that? Okay, so push allows you to modify embedded arrays in an object. Pretty good? It's pretty cool. Yep. Okay, here we're going the other way around. We're saying, okay, well, now the students know the sections they're enrolled in. Now it's the turn of the section to know which students are enrolled in that section. Right, so here we have section, and we are setting the students array of that section to be this particular student. Right, so we know that that particular student is enrolled in that section, and then I can push another student is enrolled in that same section. Make sense? So now we have the two ways of referencing each other. Everybody okay? All right.